what's up guys, this day was my favorite so far in Advent of Code. Let's see why. Camel Cards is a game mostly like poker, where we've got ace, king, queen, jack in numbers, and we're trying to make things like pair and two pair, but with a few differences. There's no flush, there's no suits at all, so that's great, and there's no straight, so that's even less to think about. But what we have more to think about is the tiebreaker. In standard poker, the tiebreaker is based on the relevant pair or three of a kind or whatever, so 3 aces beats 3 kings regardless of what else is in there. But in this game, it's based on a left to right reading however the cards came to us. So 3 aces might be different depending on where they are and what else is in there. This is only a tiebreaker, so you're not going to be comparing a 4 of a kind to a pair, but if you are comparing two 4 of a kinds, you just go left to right. So 3, 2, well, this one wins even though it's 4 3s versus 4 aces, okay? And then each hand also has a bet. Just like poker, you bet an amount and you win more depending on how much. They're not compared to a single hand, they're compared to all the other hands, so we're doing a sort of the list. So just like in the last couple videos, I'm going to show part 1 already there, and then you'll get to watch me do part 2 live, sort of. How do we do this? We got our stuff, we got our data, and part 1 says we're going to sort the lines based on the left thing when we split. So like the hand, not the bet. And then we're going to multiply the lines by the bet and their spot. So the way it goes is like the number 1 hand multiplies by 1 and the number 2 hand by 2, etc., all the way down the line. And that's just enumerate starting at 1. How do we score the hands? Well, we have 2 separate steps. We got the tiebreaker and then the pair, 2 pair, etc. Usually you call those hand rankings, but I feel weird saying rank because they use rank in a different way, and we can also use rank for cards, so it's not the best word. Tiebreaker says, well, what if we just line them up and find the index? So a 2 is less than a 9 or whatever, and it doesn't actually matter what the number is. Like 2 in this case gives you a 0, but it's only there for comparison. We're not adding them up. And then I'm using the wonderful Python structure called a counter, which gives you the count of how many things for each value. So you might say like, oh, ace, there are 2 of those. King, there's 1 of those. 10, there's 1 of those, etc. And if you sort it by the values, then it's going to be sorting the numbers least to greatest. And if we match on that, we can say, oh, if there's 5 of something, regardless of what it is, we have a certain point value. If there's a 1 of something and 4 of something else, then that's 4 of a kind. And just like up here, these points aren't real. We're not using them. We're just sorting with them. So I could say 4 of a kind is 100 and 5 of a kind is 1,000. As long as we're comparing the right greater than, less than, we're fine. So then I return those points and the tiebreaker, because when you put things in a list or a tuple, they will sort naturally by the first thing, the second thing, and so on. I guess maybe we could like splat this open and put them together like that, but it's not needed. Now, when I started this, I thought the match would be a little more abstract, like we might do things saying, oh, any amount and then a 3, but it turned out to be so specific that we don't need match case. We could use a dictionary. Well, maybe not if they're lists, but we could use if else and basic other ways of branching. I just thought the match case looked nice. And then the last one is an underscore, meaning it's the otherwise, but we could just do 1, 1, 1, 1, 1, because that's what a high card is. It's 1 of 5 different things. Anyway, if we run that on the test, it gives us 6, 4, 40, which was in fact the answer. And then if we do it on the big data, we'll get something bigger. And that was, in fact, the answer for part 1. But let's get to the good stuff. What does part 2 add to spice it up? They say, oh, the jack wasn't a jack. J actually means joker. And joker turns into whatever would be the best to make a good hand. So if I have Q, J, J, Q, 2, well, the jacks become queens because that makes 4 of a kind, and that's the best hand we could do in this situation. To balance that out, jacks are now bad for tiebreakers. And tiebreakers actually matter a lot in this game. So the funny thing is, our overall score is worse. You would think that the jokers make us, cash in the big hands all the time. But because the tiebreakers are bad and because we're sorting the whole thing and using the ranks aren't going up. Like hand number 100 is as high as it gets or whatever. And maybe the ones that had a good hand in the first round bet a lot and now they're not that great anymore, so the bet doesn't matter as much. Our score is actually lower, which is interesting. So how can we take this and turn the joker setting on and jokerify these hands? Well, the score is so similar, I almost want to keep it and not write a new copy-pasted version, but I will copy-paste this part. So I'm going to say part 2, and this line doesn't change at all. This line, we have to sort it differently, right? So I'm just going to say, what if we just say, like, joker equals true, and then we'll just add a little thing in here. If I could type, joker by default will be false, but if it's true, we'll do a little different stuff and then score them differently. Let me run it to make sure I didn't ruin part 1. No, it's still fine. Okay. So now we're going to start printing part 2 once we set up the jokerification. What do you think is the better word? We're going to say, okay. And by the way, here's the weird part of this, is that the tiebreaker and the scoring have to be separate because the tiebreaker is based on before the jokers transform into something else, and the score is based on after they transform. So we have to squeeze in the new parts right here. I can't just put them at the top of the function, even though that would be prettier. So I'm going to say if joker, then we do some stuff. The tiebreaker is different. Okay, I'll just go ahead and override. I'll just do the wrong one and then change it here, which means the jack goes first and it gets taken out of that place. So now the index for jack is 0, and again, it doesn't matter that it's a 0, it just matters that it's less than the other guys. And then the hand is going to be transformed, right? Well, this part's going to be a little more complicated, and I would feel ugly making my beautiful score function into a big mess, so I'm just going to make a separate function for that. Okay, we'll say jokerize hand. And remember, when it gets a hand, that's just a string. It's just like 5 letters. Okay. So what are we going to do? Well, I'm going to actually use the counter again. Maybe we could do it once and pass it into there, but counters in Python are pretty fast. They're just dictionaries, and dictionaries are fine. It's not the performance issue here. There might be other ones. But I'm going to say, like, okay, what's our target? Our joker is looking for what it should turn into. Like, in this one, it should turn into the 3 because there are 2 of those, and we can make 3 of a kind if there was a joker in there. In this one, we should turn into a 5 because then we can make 4 of a kind. So let's say target equals what? Well, we're going to go counter of hand, and this makes a dictionary that's like 5, 3, T1, J1. And they include a method called most common, which does exactly what it sounds like. And you can ask for, oh, give me the top 3 or whatever, but if you say no parameters, it'll just give you the top 1. And it'll just pick like whichever one it finds first, I think, if there's a tie. So now we're going to say, oh, and when they give it to you, it's like in a list and with a tuple of how many. So we have to like peel it open twice and put 0, 0, which is kind of strange, but it just gives us a letter, okay? And then we'd want to say like, oh, well, let's just replace, replace J with the target. And I think that might work on the test data. Let's try it. 5905, 5905, but that does not work on the big data. Even though I love today's question, I am annoyed that some of the tests, none of the tests capture the full range of weird things you have to look for. So basically, there's none with all jacks, or none with all jokers. There's none where the joker is the most common, but there's something else you want to turn into. And so we have to use those ideas with, you know, an exception and then an exception to the exception. We have to say like, okay, you could imagine a hand that's like JJ, King, Queen, Ace, whatever. And the 2 J's would look at this and go, oh, J's the most common, we'll turn into J's, and they're not doing their job. They should turn into something else. In this case, it actually doesn't matter what they turn into, but in a real poker, you'd want 3 aces, because that would be better than 3 kings. So let's say, okay, if J's the most common, okay, if target is J, then we would pick another one, right? Like we would say, okay, well actually, let's do that and just get the next one, right? But that's pretty annoying for 2 reasons. One, it messes up when we have 5 J's, because there's nothing else to pick. And 2, I feel silly doing the counter twice, right? Like doing this and then doing it again, even though it's super rare, I feel bad. Okay, so we'll solve that by saying and you know, hand is not equal to, so that'll solve that one. And then here we can use these little walrus operator. How about that? Very silly name. But now, if I run it on the test, it's still fine. Okay, we still get 5905. And if I run it on the big data, it'll get hopefully the right answer. Something 225. Is that what it was? Yes. Now this one was killing me earlier. I was getting the wrong answer, and it was especially annoying because it was close. It was just like a little bit too low or a little bit too high, and I was missing these parts. I was missing what if it was all jacks, or what if it was jack most common, but something else is what we need to turn into. And then I was really missing the combination of those at the same time, because this is an exception to the exception. And I'm sure there's a prettier way to get this done. I hate if statements for a single weird case. You'd rather like build it into the beautiful logic elsewhere. But at least when you're looking here, you don't see it. It's just abstracted away into this jokerization. And yeah, I'm sure you could change this where, since these are super repetitive, you could probably squeeze them into one. But that's not what Advent of Code is about. I really love this problem because it made me think about the overall pattern and then the weird exceptions. And it did it in the right order. It was not like you had to fix the annoying parts before getting to the fun parts. You got to do the fun parts first, which is always the right motivating element.